first question. What recommendations would you give to someone who wanted to obtain a physical magnitude experimentally?
Can you repeat the question?
What recommendations, okay, would you give to someone who wanted to obtain a physical magnitude experimentally?
All right. So the first. Can you repeat the question? I'm sorry.
So someone wants to get a physical magnitude. Okay,
Right.
you can think of any physical magnitude, like the K in your problem situation.
Okay.
What recommendations would you give to that person if he's going to do this experimentally?
All right. Now I get it. So like basically doing the same thing we did during the project, during the problem situation. Right. So now I get it. The first thing I will tell them to do is to simplify the process as much as possible in order to eliminate not eliminate, but minimize the amount of uncertainty calculations he's going to have to do. For example, in my case, during part number 1, I had to do a lot of equations. I used quotient, I used product, I used power. It was a lot of things. So I think it would have been way easier if before starting the project I would have like simplified the equation as much as possible. Like the actual equation I followed, which was like to find the k using w is equal to the square root of m over k and all those things. I would have changed. What I would have changed would have been like to simplify that process, those equations, and with that simplification, like now proceed to find the uncertainties of the measurements. So simplify. That's what I would say. Like simplify your process before starting. Simplify the process to find what you want to find.
And second question, what is the risk of using a model to predict a data point at a time where no data was obtained? So you took some measurements, like for the Hooke's law method.
Okay.
Yeah. And you get a model from that data.
Okay.
But then you predict a point that you didn't measure. What's the risk doing that?
All right. Well, it depends a lot if you're predicting to the future or to the past. For example, if you're predicting the sales of cars from 2010, from 2020, and you're going to predict for the future or for the past. For the past is way too risky. You cannot predict what happened in the past because a lot of things change. For example, the procedure it took for people during the 80s to produce a car. It was way more expensive than what it is right now. So predicting what was like the sales of cars before, it's way too difficult because you can the prediction of the model is not going to take into account what happened in the past. Now in the future, it's kind of different. It is the prediction might be more close, not more close, but closer than what would happen if you do it in the past. But it's somewhat predictable. You can find a correlation between, like for example, you predict what's going to happen from 2025 from 2030 in terms of car sales, and you predict it with a model with a linear equation, and you ask the linear equation to predict in the next 5 years. What's the prediction is going to be way more correlated to what's going to happen, because as long as your delta t is not as big, is not very very big, the prediction to maximize the correlation of your prediction, the best thing to do is to minimize the amount of delta t or the delta in x.
Yeah, exactly. Because we hear really change.
Yes.
Okay. Good. That's outstanding.
All right. Thanks.